Adriano Altissimo. He's the founder and CEO of Landlab. So we've been conducting a number of field trials with Landlab. So Adriano has really begun, he's an expert in biostimulants. He began his research in the early 2000s. And since then, he's really focused his attention on new ways of agriculture based on precision nutrition and plant protection on the bio economy, particularly on biostimulation. So Adriano, welcome. Thank you very much.
Thank you.
And the floor is yours.
Yes. So thank you for being here today. I have to say the Burgmeister is not here, heute, but he told me, please tell to the people they are very welcome. So you are very welcome in this Palladio villa, so which is built in the 15th century and still operating as a municipality house. So that's a special location you asked for, and then you are here.
Correct.
So biostimulant as a driving factor. This was for bio-based fertilizers. So this connection between the two, these two elements was stimulating my imagination. So, and then I went to this subject that you gave me to talk about. So at the end, there are two main drivers. So the bio-based fertilizer and the biostimulant. How do we use them? For which purposes? For which goals? Shortly, you know all that what the biostimulants are. So are products that are designed for impacting the plant's physiology, the nutrients availability in the soil, the microbiome, and bypass harsh conditions like abiotic stress and so on. And it's a market with a forecast of growth in the coming years, very significant all over the world. So where are the biostimulants in the picture of the let's say tools for agriculture? There are a kind of bridge between organic, organomineral, and plant protection. We have to say that because often we see effects which are not directly related to the disease control, but they are because the plants are in a better condition. The law is not facing this subject. The law is dividing clearly all the things, but in fact, biostimulants, scientifically speaking, are in the gray zone. A plant with a better health is a plant that copes better also with the diseases, clearly. So it's a very broad landscape, as you can see. Amino acids, humic substances, nitrogen fixings. It's really a mix and mess of products that are now getting available in the market with a sparkling industrial and research activity. Let's keep. Just, I would like to point the attention to some slides to tell you where this movement started. So starting in the early 2000s, and you see as a number of scientific publications in the last 20 years, it's not a linear growth, it's a very strong growth in the last years. So meaning that the science went ahead industry, but now science is really supporting innovation strongly. I took the freedom to look to the condition of biostimulants in different, so we have plant extracts, which is roughly just 7% of the market today. Bacteria, fungi, yeast is maybe 20% of the biostimulant market, and still more than 70% is by humic acid, fulvic acid, protein hydrolysate, so amino acids, and seaweed. So that's the main market, what we call the commodity biostimulant, not the special biostimulant, but the commodity. Bio-based fertilizers are a very wide, and I would say also wide environment. So there are so many product streams coming to agriculture that sometimes it's very difficult to separate them. So just an example. So one of your targets is to improve the phosphorus efficiency. Good. So this is an example of the difference generated by low soluble P and high soluble P. I will bring back this slide later to explain why. So the difference is very significant. This was on potato. Another key factor is those are fertilizers. On the left, you have rock phosphate, which are allowed for organic farming. On the right, you have a TSP, which is not allowed for organic farming. So organic farming, for instance, is suffering a lot by this low availability of phosphorus. The same is for nitrogen fertilizer, organic. You can see this is a curve generated by our phenotyping platform. So we measure the plant height, and you see how 7 different organic fertilizers here are giving completely different 7 growth curves. So all of them are equal in terms of nitrogen applied, but the plant performances are totally different. Below you have the untreated, and above you have the fastest one. So nitrogen is not, nitrogen title is not per se a guarantee of performances. So some effect here, for example, we have 2 organic phosphate sources and several humic acid types and doses. So you can see that only one, I don't have a pointer here, I don't, it's not working here. Okay, only one, you see AJ there. Okay, now. It's there, I don't see. Yeah, good. Only that one is able to push up the availability of phosphorus above the untreated level. The other types and levels are not able to do that. Meaning that in this case, we have a biostimulant which is boosting the availability of phosphorus above the rock phosphate level. So it doesn't mean that it doesn't mean that biostimulants per se they have an efficacy. We did many tests with the different products. For example, by looking to the available P at the end of the experiment. This is another interesting effect we found. By using special, in this case, plant extracts, by using special products, we were able to increase the P available at the end of the experiment, meaning that we were able to catch P out from the insoluble fraction in the soil pool and put in the soluble solution for the plants. Other trials are showing the same effect. So more phosphorus available at the end of experiment, meaning there is more phosphorus available for the plants. So you have some questions? Yeah. So, effect on the microbiome. This was a question coming yesterday from several people. We did see, for example, how some products were able to increase the colonization of native mycorrhiza. So not the new mycorrhiza, but the native mycorrhiza to the plants, demonstrated by this trial with this microscope analysis. But we went deeper, for example, by looking to the bacteria, abundance of bacteria in the soil during after the experiment. And we saw that some products were significantly able to increase the bacteria copies in the soil, meaning that the system was really boosted by the application. We went even more deeper, you can go, and then we went into the nitrogen cycle involved bacteria by counting the specific functional enzymes in the soil, and which are related to the nitrogen cycle, and we observed that some types of biostimulants can enhance the bacteria which are activating, for example, the nitrogen, the ammonia oxidation to nitrate, meaning make more available nitrate for the plant's uptake. So those are all data signs that say some biostimulant can enhance the efficacy, the efficiency of the cropping system. So it's not just a simple yield, but there are reasons behind. And then a good product has to be supported by good reasons behind. This slide is a summary of more than 36 trials run all over Europe in the last year. The 0 is the control for every trial. And you see that out of 36 trials, we got 33 positive on the phosphorus use efficiency. by the precise use of a very specific biostimulants. So on completely different crops in different regions, from Sicily to Finland, from potato to tomato, whatsoever. That's to prove the robustness of a product. This type of activity are needed. Otherwise, the communication and the data are too weak and cannot be spread around with sufficient confidence by the end user, by the farmers. So this is an example on how can, by the way, this was a result of a European project also on phosphorus use efficiency. So then if we couple with your goal, it's even more interesting to see that there are many possibilities to enhance the system. So at the end of the story, how shall we use this product? So we have a cropping system with different physiological phase. Then we have to increase, for example, the nutrient use efficiency, but we have several critical events like drought, heat wave, frost, or UV. And we have plants that we suppose are in comfort, but maybe they are not in comfort because we can control some factors and other we cannot control. So when do we use that? The key factor to me to enhance the efficiency of the crops is to deal with these elements. So we have to know the weaknesses of the cropping system in the season, depending on the crop, location, soil, climate condition, and so on. We have to know precisely how the bio-based fertilizers are working. When the nutrients are released during the season, if they are released in a sufficient speed, or they are too slow, too early, too late, according also to climatic conditions. And we have to know very well the biostimulants to apply in a very precise moment, because those are not products that can be used in any moment of the crop cycle, but they have to respond to specific tasks, to specific claims, when they can make their job. So at the end, set a precise plan according to external conditions, which are the driver of the plant's growth. So the conditions are the drivers, the products are the support. Both things have to be put together and applied, used in the right way. So at the end, we can have a nice portfolio of solutions which combined together really are able to enhance the cropping system efficiency. So this is our conclusions of the activity we are running. And then I would like to share with you, because it's giving another level of integration, another level of research, another level of investment needed to better understand and use these possibilities we are generating.